Alright, so today we're going to talk about finding uncertainty using error in measurements. So this usually comes in two types. First, there's an absolute uncertainty. And this gives us kind of an exact amount of uncertainty within something. So for example, if you go to mass something on a scale, and you've calculated out that it has an uncertainty of 0.2 grams. So we got 4.2 grams plus or minus 0.2 grams. Essentially what this is telling us is that somewhere in the range of 4.0 and 4.4, in other words, minus 0.2 and plus 0.2 grams is our actual measurement. Then there's also something called the relative uncertainty percent. And it's just a similar way of representing the same type of uncertainty. So for example, we know that this is 4.2 plus or minus 0.2 grams. We essentially put that 0.2 grams into percent of the actual measurement. So here we'd say 0.2 divided by 4.2 times 100%. And if you did this, you would find out that this is 4.76%, which is about 5%. So our error here, or a way we would express it, is 4.2 plus or minus 5%. And so knowing how to do these two, and even go back and forth between them, becomes relatively important in propagating error throughout a calculation. So let's do a calculation. Let's say that you have a beaker, and in that beaker, let's say you throw some things in there. You throw something that has a volume of 20.1 plus or minus 0.2 milliliters. And so you've got something in there, and then you add an additional aliquot of something, let's say 10.5 plus or minus 0.1 milliliters, and you've gotten these errors via the glassware information. All right, and you want to find the volume in there. So you want to know the volume. Well, until now, you probably would have just added this plus this, and you would have, and we're assuming that volumes are additive, and you just said 20.1 plus 10.5 gives me 30.6 milliliters. And you'd be right, but we still have to account for these errors. So whenever you do a calculation, you have to ask yourself, what type of math did you do? So here we added. And when you add and subtract, it's going to be different than when you multiply and divide. So when we add and subtract, what we're going to do is to find the error, or the uncertainty, excuse me, is going to be equal to the square root of each of these errors squared and summed. And if you do this calculation, you will find out that this equals essentially the square root of 0.4 plus 0.01. And if you calculate that out, you'll find 0.223. So when we go back to maybe answer our final question, we knew that it was 30.6 milliliters plus or minus 0.223, but here's the thing, you want it to be just 1 sig vig. If I round that error to 1 sig vig, I get plus or minus 0.2 milliliters. Another important thing is you want these places to match. So this is the tenths place. You also want that to be to the tenths place as well, especially when you're expressing uncertainty. And that would be your answer for when you add and subtract. This is the process that you go through. Let's move on to another example. let's say you're multiplying or dividing. So for example, let's say you find an object that's got a mass of 4.12 plus or minus 0.02 grams, and you want to find the density of it by taking that mass and dividing it by the volume it takes up, which is 1.01 plus or minus 0.04, let's make it 04 centimeters cubed. So I like to start with the easy stuff first. I like to say, okay, we've got 4.12 divided by 1.01. So we're starting with 4.08 grams per centimeters cubed, because it's easy to forget this simple thing when we're focused on the air. Next, we have to ask ourselves what we did. We didn't add and subtract this time. Instead, this time, we multiplied or divided. When you multiply and divide, we're going to use percent error, much like we did at the very beginning of this video. So, first, we're going to want to figure out the percent error of this 0.02 to the 4.12, and then the 0.04 to the 1.01. So the percent error of each of these is 0.02 grams over 4.12 grams times 100%. Here I get 0.4854%. And I do the same thing for the other value that we ended up dividing by, which is 0.04 divided by 1.01 times 100%. And when I do this, I get an answer of 3.96. Now I like to keep a couple extra sig figs. I don't want to round at all until I get to the very end. And so now I'm going to calculate the uncertainty. And that will simply be the square root of each of these percents squared and added together. If you go through and you calculate all this out, you'll find out that you get a 3.99% uncertainty. And just like the addition and subtraction, you're going to want to round this to 1 sig fig. So we end up getting an answer for the density of 4.08 grams per centimeter cubed, plus or minus 4%. Now there's something else I can do. This is the percent uncertainty. I can also report this value in absolute uncertainty. And that will provide us that range that we were talking about. Simply by knowing what 3.99% of 4.08 is. And if I do this, I find out that it's 0.163. I'd want to round it to 1 sig fig. And that'd be 0.2. So in expressing my absolute uncertainty, my answer would be 4.1 plus or minus 0.2. Again, because this is to the tenths place, I round this answer to the tenths place as well. And that is how you calculate uncertainty.